Good. Everyone okay on 11? Well, supplier of TI-83 calculator claims the average life of calculators is at least 8 years. A sample of 12 calculators reveals the following lifetime. Test the supplier's claim at the .05 level of significance. Assuming the calculator lifetimes are normally distributed. Okay, how do we do a test? Is this my soda here?
No.
It's yours? How do we do it? This is a test. There's only one kind of test we can perform, right? Hypothesis test. Hypothesis test. All right, so what's a hypothesis? What's the first hypothesis? The whole hypothesis is what? 8. What's the alternative? Greater than 8, right? At least 8. That shows direction, right? No longer 8 would be, is not equal. It's different from 8, not equal. Okay, but this gives us direction. At least 8, so it's greater than 8. Okay, so now we got to throw that in the calculator and figure out an average and a standard deviation. Okay, do you want to do that real quick? So go ahead and put those numbers in the calculator and we'll get an average and a standard deviation. 'Well, no, you just got a list of 12 data points.
Oh.
Just put them in any list, doesn't matter what one.
Oh, like the other test with that probability distribution.
Discrete. If you have a discrete probability distribution, you have to use 2 lists.
Like that whole.
The TV sets, yes. Okay, so what's our alpha value? 0.05. So what's our test look like? Okay, this is 0.05, this is 0.95, right? Okay. So now we have to find our critical value. How do we find our critical value? Our critical value we find from the t-table, right? I'm looking at alpha equals 0.05, 1 tail. What's my degree of freedom? 11, right? I got to take 1 away from my sample size. What's my sample size? 12. That's why I got to look at the 11 row, degree of freedom, 11. Okay, when you do that, what do you get for the t-table value?
.796.
1.796, is that what everyone got? 1.796. Yeah, they should be a little bit more precise because they switched books. The old book was ends less than 30, you go to the t-table. New book says if you know the standard deviation, use the normal. should have been a little more precise in the problem. They didn't rewrite the problem. Okay? Strictly speaking, if you knew the standard deviation, you would use the normal table. But clearly you don't know it because you only sampled 12. Okay? 1.796. Now we have to do what? We have to do our test stat, right? Our test statistic, which is what? X bar minus the mean divided by the standard deviation divided by the square root of n, right? So in this case, what's X bar? What do you get from your sample?
7.80 or 81.
7 point, what is it?
7.81.
7.81 minus the mean, which is 8, divided by the standard deviation, which was, please? S.
Is it SX or the?
Be definitely S.
Okay.
0.277 divided by the square root of 12, which in this case is 12. N is 12. So 7.81 minus 8 is negative 0.19 divided by 0.277 divided by the square root of 12, right? And someone's going to give me a square root of 12. It's 3 something.
3.46.
Negative 0.19 divided by 0.277 divided by 0.3. Oh, I'm sorry. What you said was 3.46?
Yeah.
And when you divide that, divide it into negative 0.19, what do you get? Negative 2 something? What you get? Negative 2.39? Yeah. What do you get? What's 0.277 divided by 3.46? What is it? I'm sorry. 958. Is it a negative 0.19?
That's right.
What is it? Negative 2.37. When you divide that, it'll look right.
I got negative 2.37. That's what I got. 0.19 divided by 0.958. Negative 2.37.
2.37?
Negative. I have 0.8.
What do you have? I don't think 0.958 can't be right because. Yeah, that looks better.
Yeah.
Point 8? 0.08. 0.08. You got something wrong with that calculation. So negative 2.37. And where is that? That's over here. What is this? Do not reject. This is what? Reject. Okay? Does that make sense? Why does that make so much sense? It's clear. It's clear as an eagle flying in the sky. The majesty of that is that clear. Why isn't that clear? What are you testing? You're testing what? See if the mean has gone up, right? You're testing to see if it's gone up. You went out and took a sample, the sample went down. Is there any possibility you can believe that it's going up if your sample was lower? That's it, right? I mean, game's over, right? Everyone see that? You went out and you did a sample. You got an average of 7.8. Is there any possibility you could believe the average went up? It's above 8 if your average is below 8. No, there's no possibility at all, right? Clearly, there's no possibility. All right. Anyone see that? That'd be like saying, the average income level of students who graduate with a statistics degree, I believe to be $65,000. Okay? And I think it's gone up. They go out and they do a sample of 12 students. I found the average to be $50,000. Is there any chance it went up? No, there ain't no chance it went up. Same problem. Okay? We believe that it's above 8. We went out and did a sample and the average is less than 8. No chance it went up. Okay? All right, does everyone see that?